想关。
Hello, okay. Yes. Good morning. My name is Eckhart. How are you? We soon start the presentation. We are soon finish the preparation. Okay. Yeah. Okay, we need to try again. Okay, one, two, three. Hello, my name is Eckhart. I'm here at the Ucera booth in Guangzhou. Is it okay? Good. Okay, perfect. my daughter. Okay, now with a little bit a delay. Okay, I start, no? Okay. Yeah, my name is Eckhart Singh, 123, and we are son, and I'm here on the exhibition in Guangzhou, South Dental China. The dental show in South China, and it's a booth at UCERA. And what is the topic now? I just want a little bit talk about the digital workflow, what you all need and what you have to watch carefully about the digital workflow. This is a picture from my hometown, Charlemagne, the old Emperor. In his older age, he teach children and young people that they have to learn writing, reading, and a little bit mathematics. And he said, first you have to study the knowledge, and after this you can do the practice. And this is what I follow here too. Yesterday I give a lecture and about veneer, and yeah, it is always better to hear something is not too good as to see. This is a one important sentence. But to see something, yeah, is not too good, not enough for understanding. Yeah, you have to hear, you have to watch, but this is not enough that you understand the whole process. To understand something is not as good as to create. So learning culminates in creation. So you need to take action, practice what you have here, and then you can show this the master. He will correct you, and then you try again. This we call in Germany the 4 steps for learning. So it is really normal that you make mistakes and something fail, but this is not the big problem. Yeah, fails and mistakes belong to learning. Okay, that's just about this. Yeah, what means digital workflow? Maybe the most people from you around the world, you know, and but I want a little bit repeat and remember you. What means this? CAI, yeah. I call it the computer aided input. The other call it computer aided innovation. The third one is CAD, CAD. This is everybody know. Computer aided design. Yeah, we do it with our software. And CAM, computer aided manufacturing. Yeah. Some translates this with modeling, but this is at last the same what you like. The new one, of course, not new, is a 3D print. You can split the case. No, not anymore. The input is digital and the output are teeth. and all this is on the digital way. In the future we need much more specialists than dental technician, but at last a dental technician know how the teeth looks like in the mouth. This is my point of these lectures always, in my experience. We have the work steps after the milling process. Yeah, we cut from the blank. Then is sintering. Sintering is important step, and of course we have some analog step at last, the staining in glaze, some individualize of our CAD/CAM work, and this is still a little bit analog, and we are artists. This is handcraft still. This will be also in the future, maybe in the next 10 years, our job, and then the machine coming. Yeah, conclusion is from all this, different material use a different workflow. One moment. Okay. Now, we have also digital workflow and what is also hybrid manufacturing. What is this? Yeah, this is always my picture. I show how the people have different material in the mouth. Some alloy, some maybe copper, gold maybe, and some PMMA. But he can still use it and chewing and eating, and he is happy. Have a dinner. Why not? Okay, we can do it better. So this is the point. What I want to show you. We have also different. This picture is a main picture for my lecture actually. Yeah. For example, CAI, so computer aided input or innovation. This is the LED scanner from Ucera. Yeah, high accuracy. Yeah, this is a good scanner. I use it. And for the dentist, of course, the intraoral scanner. This is the other way, and some dentists use it already. So not take any impression. Yeah, this is very convenient for the patient. You know, if you take in the upper part the impression material, the patient feel not very comfortable, and they think, and the accuracy is also sometimes so. And I already use this intraoral scanner, and it was real, very high quality, high accuracy, and I don't use for the cases not any model anymore. This is in the last step. Yeah, maybe you need to adjust some contact points, but this I will talk to you later. After this step, the CAD step, the computer edit design. What happened? You always start with the order form. We have different softwares on the market. You know, you have to fill the order form very accurate. Any mistake, if you forgot to splint two crown and the dentist want splint, the result is these are single crowns. So you have to really read and watch carefully the order form. I do some mistake. I think, hey, what is this? Or I mark the wrong teeth, or I miss a pontic, and suddenly I need to sign the margin on the wrong teeth. I think, what is this here? What is here wrong? Yeah, and then I go back to the order form. It was my mistake. I put the same, the wrong teeth on the order for the crown, whatever it was. And it was not the software, it was not the machine later, it was you, the human, who makes the mistake. Don't forget this. The next is after you have the input, you order form, and then scanning the model. Yeah, here is also this. Actually, this is this step here together. Yeah, scanning and modeling. You use the information from the scan for your manufacturing or modeling, and then this is now the point where you need to be a technician, or minimum maybe 3-6 months you need to work in a dental lab and how to know what is a teeth, how the patient, how it looks like, what the patient wants. This little bit background knowledge is important, but everybody can learn. So this many people can do. After few months they create a lot of units. They can do it very fast, really very quickly. In this CAM software, or maybe already now in the CAM software, you have to decide the material. They will ask you what kind of material you want, and this is different. You have alloy, non-precious alloy, you have semi-precious, you have maybe some labs they have gold, still high precious, very rare, but they do it. But the most what they now use is zirconia, and in the world, I don't know the exact number, but maybe over 30%, 40% is zirconia. Some lithium disilicate, and the other half is still non-precious material. And to casting non-precious, is really difficult. In my own lab 20 years ago already, in Germany, in my small lab, I use already the scanner and the digital workflow. I'm not casting any more non-precious. So many mistakes happen, so many fails, and you have to watch this, and the bridges are rocking, and. With this now, the digital workflow, you can choose in the I will show you later, laser smelting, 3D printing, or milling. Good. Then you choose the material, zircon or lithium disilicate. So this is dry milling, this is a wet milling. Of course, this is a bit depend from your machine. You can give it to another lab if you don't have the machine. So this is also possible. This step here, maybe this step your customer send to you. This you can do. You can send this to another place, in a milling center, or you do it by yourself. This is the best thing of the digital workflow. You can send it around the world, the data, and in 3 days it will come back ringing at the door, and the bridge and the crown is there. This is after CAM. Actually, we use this CN software, computer numeric control, CNC. So the machine cannot read this, the machine can only read this, so there is another software who changes the software to the machine reading software, yeah, and then we have this process, yeah, I go this side, yeah, this is a subtractive process, so you cut something, and this here you can change to the 3D printer. This is the additive process, yeah, including for non-precious, of course, yeah? Model everything, also from Lucera. You have now the model. The crowns are on the way. You cut them, you put them in the sintering surface, yeah, and then you have this. For example, I use this Swedish, and then later staining, and then finish. Yeah. So this is actually the digital workflow with a little bit at last analog, some handcraft, but the most is real by digital way, and you have so many chances to use material, and you can correct. And the good thing is also from the digital workflow, it happened to me in my in the dental lab, and the patient crack the crown or the dentures, yeah, dentures also very easy. You go in the data file, you can milling the crown, or the denture, whatever, and a few days later the patient is done. Yeah, this is also the good thing for the digital workflow, because you have still the data, and if it is not too long time ago, the crown and denture will be perfect matching like the same before. Of course, after 2 years, 3 years, maybe this is difficult. This is not so good matching. Okay, we go ahead. Computer added input. Now, this is what I taught. You have to create here this order form, yeah, and for example, this bridge. Don't forget here this mark here, this connector. If he is a Pontic, this will become automatically, but if you have here, for example, only 1, 2, 3 crown, yeah, and you want splint the crown, you need to make here the mark, yeah, for example. Huh? And yeah, this is also belong to the intraoral scanner. Yeah, this is the output is this data file, yeah, from Lucera, and again, this is really very accurate, and I like it to work. Yeah, now for example, the intraoral scanner work. Yeah, the intraoral scanner is at last. It is a small camera. You put it in the patient mouth, yeah, and the rows of teeth you are scanning slowly, like buccal side, occlusal side, lingual side. You go from the distal, you go to mesial, and then you go back to distal. So there are some rules for every scanner how to do it, but the result is real very accurate. Yeah. For example, I take this picture, I don't know, and yeah. And what is the benefit? Ne? It is very precise. You not take a manual impression. no disinfection, no transport, not longer process. The dentist takes the impression and then need a long way to the dental lab. Many things could happen. The accuracy of the impression, lose something. And the patient is also very happy, especially in the upper, no clean in the mouth, that he warm, and I think the digital way is very safe for the control. Good. And the data you transmitted to the dental laboratory, forms of the database, CAD/CAM design of the denture. The dentist can do it, or just send the data to the lab. They create the dentures. They can be made from different material now. There is the base of the denture and the teeth together in one blank, black and blank, white and red. And zirconium oxide, of course, the zirconium is the most used material in the digital workflow, and chromium, cobalt, molybdenum, alloy, framework. The framework you can milling, you create the framework in wax or in PMMA, then you can casting, or you are milling, what you like. The night guards are milling, for example, some also 3D printing for the night guard, and models and dentures, of course. So you have a lot of things what you can do with these data files. If you scan, of course, there is no blood, or salvia around the stump teeth. If it is bleeding after this process of the preparation, the dentist have to tell the patient, come in 2 or 3 days, and the bleeding is stopping. I can very accurate take a scan, but with blood is not possible. Okay. So we come now to the computer-aided design. I have here some pictures, for example, just prepare the margin. You need to, if you have not the intraoral scanner, you use the lab scanner and you scan the model. You have very carefully prepare here this margin. The scanner need to be recognized. Of course, here this sharp edges need to be with some wax, make it a little bit rounder. The milling machine cannot do it when the milling machine go in the crown and needs some space. If this is not working, please make it rounder also here. And then this is the sign, for example, So this is our sample model from yesterday. Inlay, onlay, veneer, some crown. So here you can decide in the posterior area, maybe you create already a little bit more space, because it could be happen that otherwise the dentist polish too much in the mouth, and you need a contact, of course, but on the model, in this case, my experience is in the posterior have some more space, but it is all depend from the process you have to communicate with your customer. Of course, for the German attachment, so-called telescope attachment, I do it first layer already milling, for example, and after they come, I put it again and I control the direction if it is parallel, and then we start the second layer crown. I do it by with panel design, yeah, but this is also now very common, all digital, yeah. They have a tactile scanner, so they have two scans. They put this together, and but this you have a little bit to try that the second layer crown and the framework is real good matching. Okay. Go ahead. Yeah. Now, for example, here a big bridge. Yeah. With non-precious and just design, and you can use the situation model. You can scan the before, the old situation. You can matching this mesh with a design. You can see we do it a little bit like the old one, but the paging sometimes want a new design. So in the digital way, you have really much more options. Yeah. The CAM software is able to translate the CAD design instructions for the machines. I told you need a software to put the CAM in the CNC, and then material is zirconium dioxide, PMMA, non-precious, lithium disilicate, glass ceramic, 3D print, laser printing, PEP and wax. So this is all you can do. Yeah. Good. So, what is zirconium? I use here this color multi-layer disc, yeah, which is main ingredients is zirconium dioxide, hafnium is 98. This is the other color. They create the color, the shade. Yeah. This is a real good zirconium multi-layer. I use it, and I had also here afternoon again a lecture to show you I use this material for this case in the anterior, posterior in one single crown. The white disc, yeah, some dental labs they already almost still layering, and they use this, for example, so-called a white disc, yeah, ST or HT, yeah, super translucency and high translucency. You can use, yeah. The wax PMMA I use also many times already. Yeah, the transparent for the night glass. Yeah, for the splint, whatever. Yeah, and they use this for casting inlays, onlays, veneers. Yeah, they use the wax. Then they are pressed in ceramic, whatever. Man. This is also all from Ucera. Yeah, Ucera also uses lithium disilicate glass ceramic. And yesterday I gave a lecture about a veneer, and we cut back in the incisal area from this veneer and layering with some ceramic material, and it looks very nice. I hope you have yesterday attended this lecture online. And again, here is the workflow, scanner, design, cam, milling, shape adjustment, and then crystallization and glaze. So this is a very easy workflow for many people. In the dental clinic they can do it. The employees can do it. Yeah, computer aided manufacturing. We have some implant crown abutments. Of course, this is also very common. The implant. Here is the analog, the implant. You have a customer side abutment maybe with the emergence profile on the tie base. Yeah, here is a tie base. This is in zircon. Yeah, and then the crown, very nice, especially in the anterior area. Yeah. Again, some pictures from the implant telescope here. Yeah. Okay. I like it here. This edge is a little bit too sharp. Maybe I will make it a little rounder. The big full mouse arch, non-precious bridge, implant bridge. You can also do it in zirconia, of course. This is a cam non-precious, for the digital workflow. Okay. So in my first lecture on Monday, I already talked about the correct design for zirconia, anterior, the thickness, connector. Please, interior single crown, the thickness 0.9 millimeter. It's okay. You have a 3-unit bridge, long plane bridge, the interior all 0.9. The connector cross section 9 square millimeter. This all you can choose in your software. I choose sometimes a little bit more, 10 to 11 square millimeter. Posterior thickness a little bit more. You see, this is 0.9, this is 1 millimeter, and the connector 12. A little bit more is better. Here are the milling machine from Ucera, and they use milling machine they have different tools. You can buy the tools from Ucera for Amangoba, different machines if you want. And here is this interior bridge, for example. Dry milling 5-axis. It's a 5-axis machine. You can see here this in Guangzhou, well working. The wet dental milling machine is here. So what they're doing, they can put 8 different materials at the same time. They have a very nice holder. So this means 8 veneers in one time you can milling. This is very, very fast. And lithium desilicated. She can also milling titanium. And again, drilling is not milling, and milling is not drilling. This is a little bit different. Don't forget, nah? Milling is milling. What they're doing, the birds, tool magazine, 10 tools, you have 10 tools in this machine, and for the first layer, telescope or called inner crown, full crown bridge, again telescope, abutments, inlay, full crown veneer. All this you can do with this machine, the new XRC 6X red dental milling machine, and okay, you can. 3D printer, this is the other output, additive and 3D laser smelting. This is a 3D printer, the new one from Ucera, so you can use it for the dentures and for the models, and for the night guards, and you see 1, 2, 3, 4, 5, 6, 7, 8, 9 models in the same time. You have an intraoral scan, and actually no model, but you can deliver your crown, your bridge, on a 3D print model to the dentist, to the customer, if he asks for this. And there is always a little bit adjustment, but it is not real a lot. Plastic 3D printing is additive process with material which is built up layer by layer, and the printing direct, the direct implementation of your digital designs into physical one's objects without any mold and make not any impression. This is the point of 3D printing. This is a new one, from Ucera. You see what you all can use for the splint, or the night guard, dentures, temporary crown, surgical guide, occlusion model, restoration model, casting crown. So this is also very nice. Temporary crown. If you create a temporary bridge crown for the patient and he is happy, or maybe you adjust a little bit, you can also scan this and matching in the CAM software that you can use it for the final design. So the patient wears a temporary bridge, and what he receives is the same, the copy later in zirconia, and this is a little bit funny, and the patient is always surprised how this is working. Now, again, the parameters, the Z-axis. Okay, you can also have a look here if you think, or maybe on the IDS. In Cologne, this month. Laser melting, is a digital successor for the traditional manufacturing methods, such as modeling and casting. How to do it? There is a laser pointer and data. They create the three-dimensional construction data layer by layer in the metal structure, and they build up one by one. And I go not here deeper, this needs always too long a little bit, but you know what I mean. Laser melting is the digital successor to the traditional manufacturing, definitive. I use it also for the non-precious crown bridges. I use this laser melting, and it is real funny how accurate, and it is everywhere. It's 0.3 millimeter thickness, everywhere. I cannot do it this by hand, so fast and accurate. This is really, really good. Good. Yeah, sometimes they call about hybrid manufacturing. Yeah, what is this? Hybrid manufacturing. It combines the strengths of two advanced technologies: the additive manufacturing, laser melting, and the subtractive manufacturing. So first they build up in 3D laser smelting, and then later they put this in the milling machine, and they milling this a little bit more accurate, and this is a combination. They call it hybrid manufacturing. Not many factories do this. Yeah, this is the maximum of design freedom. The fit relevant areas then reworked in a CL milling machine to achieve the highest precision and smooth surfaces. We know the 3D printing crown, the surface is a little bit roughly, and then they milling this again to a very, very smooth surface. Yeah. The work steps after milling process. Yeah. Okay. I already showed this on Monday. You use this instrument to cut the connector. Yeah. Like here. And then you use the silicone rubber to make the surface smooth. And please don't forget, you have to wear a mask, yeah, and start the exhauster, that the zirconium dioxide dust is away and not to your lung. This is actually not so healthy if you do it many years. You use a very, very fine fissure. You go through the fissure, yeah. This zirconia is a little bit soft. You can very nice make the adjustments in this step, and I think this is much better than after sintering you can do nothing. Do it in this step. This is much better. If you want to change something in the connector, make the interior teeth looks like separate, then do it in this step. This you can do. And what is the next? The dust from this process you have to clean by a brush, maybe air, okay, but when you put the dust in the room, it's not so good. If you use rising water, it's also possible. It is very clean, but then you have to dry the zirconia framework. This is another step, another process, and need also a little bit long time. Yeah. So better is only use the brush that the dust is away, and then you can start the sintering process. Yeah. Sintering, what is this? The sintering process, then the zirconia transfer to another crystallization. This means high temperature, around 1500. And again, I mentioned this also on Monday, the calibration of the surface is very important. Yeah, it's really important. There are the heating elements, and in this furnace are the heating elements, and how many times you use. Maybe once a year you need to change the heating elements. The new one is you use this double tray, yeah? So you can put a lot of units in this sinter furnace, and it needs around, the process is around 11-12 hours. So mostly we do it overnight. Yeah? Here is this sinter pearls. You put the object in this way, and then you start the program. Yeah. Here is the sinter curve. Yeah. 1 to 5 units. Yeah. The time here you can see. First stage is 7.5. Second stage 3.4 centigrade per minute. Yeah. This is the cool rate down and temperature. Okay, 1500. So 1 to 5 units. You have to watch. I show you the next picture. 6 to 10 units. It is already bigger. The first stage rate is 4 centigrade per minute, and the heating rate in the second stage is much slower. I go back. Yeah. 7.5, 3.4. Wait. You see 4 and 3 already change, lower, slowly, and here is also 3 centigrade minute, and here is only 2 centigrade per minute. Hello, yeah, nice to see you. So, now
explaining about the digital workflows.
Digital workflow, and maybe layering the ceramic or polish or glaze. But before you do this, you have to think about abrasion. The abrasion. Zirconia is a very, very hard material. It is real very harder than the enamel of in the teeth. And when you adjust the occlusion, this is happened every day. They use a diamond, they use a grinder, ceramic grinder, in the articulator. It could happen. You have to polish this zirconia surface very flat, because if this is very, very rough, it is like a tool against the antagonist. Yeah, you need to do it. Okay. Please polish after, check the occlusion, adjust the occlusion, polish the zirconia occlusal surface. Note this. It's very important. Glaze alone is not enough. No? You see, it is only glazed. But after the abrasion, the material should use millimeter. If you are polished by hand, nearly nothing the antagonist can polish away from the material. Nearly nothing here. Very, very less. I use these tools for adjust, the diamond grinder for zircon, and different shapes, of course. Ucera, also you can buy from Ucera, ask them for the whole package, for the blanks, for the milling tools, and for this grinder. So you have a good supplier, and this will be fine. These are the polish instruments, yeah, different shapes here for the fissure. This one, yeah, different steps. You go a little bit with this middle and then fine, so that you have a high glossy, and actually sometimes no need to glaze anymore. Yeah. But of course, glaze you can use it for staining. Yeah. Okay. So this is a polish and glaze and stain set from Ucera. I use it already, and I show it here also on the exhibition. 780 centigrade is a final glazing temperature. Yeah. And again, for single crowns unit bridge, like in the sintering process, we have different time, different steps to get the zirconia slowly warm up. Yeah, this is important. Yeah. This is the glaze and stain set inside. Yeah, and yeah, there's everything what you need to glaze zirconia. And the lithium disilicate, of course, this is for every material, not only from zirconia. Yeah, what is the conclusion of this? The digital workflow is a very efficiency way in our laboratory to produce teeth, dentures. The old analog way is still required in many steps, but the future is digital. It's already now, we know. Yeah. Maybe zircon, lithium disilicate, glass ceramic should be in the future produced by 3D printer. You never know. The human assessment is still required. There is no doubt. We need the dental technician have a good education and they know the material, how to use it. This is still required. Yeah. The crown, bridges, teeth, dentures will have to be clinical, adjust. Yeah. It is still a little bit clinical adjustment to achieve the balanced occlusion and shade. So this is my conclusion. Give it to you, to the world, to the technician, and keep it in your mind. This is the fact of the workflow. Of course, if you have any question, ask Ucera and we will answer you. This is sure. And now I say thank you very much for your attendance, and maybe see you next time. Thank you very much. Okay. Okay.